Dear viewers, in today's session, we will discuss about that how we can protect our grid system from different types of faults and blackouts, and how we can select proper safety equipment, either it's a circuit breaker or relay coordination. So today we will discuss about the short circuit analysis and circuit breaker selection criteria, and then we will conduct some simulations in PowerWorld that how we can analyze the value of short circuits in a particular grid and how we can select a circuit breaker. So let's quickly jump into the simulation. So here is an available grid of almost 40 buses, and here I have different voltage levels from 345 kV to almost 69 kV and 138 kV. So there are different buses, like this one has 345 kV, this bus has 138 kV kilovolts, and then here are some buses of 69 kilovolts. So these are the buses we will conduct. On few buses we will conduct simulation analysis. For simulation analysis, first we have to switch from edit mode to run mode in PowerWorld, and then we have to simulate it for load flow analysis. So this is the flow simulation, and here we can go into the case summary, and we can observe that how much load is connected and how much power is generating. So there are some losses of almost 11 megawatt and 50 megawatt. So this is the overview of this system. And after simulation, after load flow analysis, we have to conduct the fault analysis. From here we will do fault analysis, and then what type of faults we want to conduct, either it's bus lines or generators. So let me take you back to the simulation file. Here I will conduct some simulations on this 345 kV lines, and this 345 to 138 kV transformers, these transformers. So let's go back to the fault analysis, and I would like to conduct line online that I want to conduct, let's say, this 345 kV line. What is the fault type and where is the location? Either it's a bus fault or a line fault. So I would like to, it is a line fault. So again it's asking about the location of the fault, where it is located. Again, the 345 kV bus is connected with two buses. One is 345 kV and another one is 138 kV. So I want to conduct with this bus, the 345 kV bus. So it is highlighted in yellow. At which location? Let's say I say that at 50%, at the mid of the transmission line. Let's say I assume it that it's at the mid of the transmission line. And then what type of the fault is, either it's a single line to ground fault, three phase balance fault, line to line fault, or double line to ground fault. So again, if I want to check values in per unit, so it will give me a per unit values. And if I want to in amperes, then I will switch into amperes actual values. So again, here is the some scale current by, so here is some factor we have to multiply. So for as per NSC rules, we have to select a circuit breaker which has which has a short circuit value of 125%. let's say the short circuit value is 100 ampere, we have to select a circuit breaker of 125 ampere. So here we have to scale it for the circuit breaker selection of 1.25. So let's say I am calculating this fault, single line to ground fault at mid of the transmission line of 345 kV. Here I will calculate. So this is the values in per unit. So it provides a per unit value. Again, I would like to switch into amperes. So here is the values are in amperes. So the actual short circuit value is 4.775 kilo amperes. So if I scale it for circuit breaker, I will select a circuit breaker of this value, almost 6 kilo ampere circuit breaker will be sufficient for interrupting this fault current. So this is the single line to ground fault. Again, if I want to conduct three phase balance fault, again calculate it. And then here is the scale actual value of 5.5 kilo ampere and scaled value of almost 6.8 kilo ampere, you can say 7 kilo ampere. Again, I would like to conduct line to line fault. Again, I will recalculate, and then the value is 5.8 kilo ampere scaled value. Again, for the double line to ground fault, I will recalculate the values. And here is the values of 5.37. So what the maximum value I get from this simulation is almost 7 kilo ampere. That was, I think, three phase balanced value. So I have to consider this value for the circuit breaker selection. We have to consider the maximum possible fault current value for circuit breaker selection. So this will be the value of circuit breaker selection. So let's jump into the circuit breaker table, where we can select a circuit breaker with the which has a voltage rating of 345 kV and short circuit current of 7 kilo ampere. So here is the table for the circuit breaker selection, and here's the nominal voltage class. So where it is, it's for in kilovolts. So I will go into 345 kV. So here is a two circuit breakers, one of 345 and another one of 345. So what is the rated maximum voltage is 362 kilovolts, and then continuous current in the this for this circuit breaker is 2000 and 3000 ampere, and then rated short circuit interrupting value is 40 kilo ampere. So it can interrupt a short circuit current up to 40 kilo ampere. And then we have to interrupting time is so it's a 3 cycle and 2 cycle. So which we have to select a circuit breaker which can acknowledge the short circuit in a quick time. So we have to select the circuit breaker with the 2 cycle one. And then other ratings of rated maximum voltage and maximum symmetrical interrupting capability. So we have to look into this criteria. Let's go back to the simulation. So here this indication shows the fault temporary bus. We have conducted a short circuit. If we want to go back to our studies, so this is at the 50% we have initiated a fault analysis between the oak 345 and slag 345. So and this is leg 345. Here is at the mid of the transmission line, a temporary bus that shows the fault value. There is another way we can conduct for short circuit analysis. Let's say if I want to have a check this bus, the fault analysis. Let's say I am clicking over here. Here I have an option of fault. I can initiate a fault at that bus at that particular point, and it shows that. So the other way of conducting fault analysis at a particular point, I can click on this transmission line. Here I want to check the fault value. I have to click on this. It will pop up the fault value. Here I have to click on line. So it automatically shows the location where I have clicked, that at 23% from that particular bus leg 345 to ELM 345, that fault I want to conduct. An inline fault at per unit value or in amperes, I can conduct the calculate the values. So it will be the 6000 ampere short circuit current, and if we want to scale it up to 25% and again calculate, so the actual value will be 6000 ampere almost, and the scaled value be 7.5 kilo ampere. So this is the way that how we can conduct short circuit analysis at transmission line to find the short circuit current values for the safe installment of circuit breakers. So next we will move to the uh, short circuit analysis of buses. Let's say I want to conduct short circuit analysis at the 345 kilovolt buses. Let's say this bus I want to conduct fault. So here I can go into fault, and it will give me an option to conduct the fault at OC 345. So it is a bus fault, and it is single line, and I want to 25%, 125% scale value, and single line to ground fault will be 3036 100 amperes, and the scaled value be almost 4600 amperes. So this is single line to ground fault, and then the three phase balanced fault. So here is the three-phase balance fault is 4.7 kiloampere and 5.8 kiloamperes. Line to ground to line to line. Again, I have to calculate, and here it will be line to line calculate. You might be wondering that what these buses shows. These buses that shows the value at each bus. That's per unit values of buses. So it's voltage at each particular bus and phase wise. Again, it's an angle deviation, and then we have to conduct double line to ground fault. So we have to select a maximum value of I think it was for three-phase balanced, and it is almost 5.8 kiloamperes. So we have to select on the basis of this value. So these are the different types of conducting short circuit analysis on buses and transmission lines. We can similarly conduct short circuit analysis of at this bus 345 kiloampere, and then we have to conduct uh, at these transformers also. So this is the values for again I want to conduct the fault at this transmission sorry bus 345 kilowatt. I have to click on this bus, ELM 345 or go to the fault analysis. So again I want to conduct bus record ELM 345. This is ELM 345 bus, and now I want to conduct uh, short circuit analysis. So it's a 7.7 kilo ampere, and again the scaled value is 9.6 kilo ampere, and then three phase 8.5 kilo ampere, and line to line fault 7.1, double line 11 kilo ampere, double line to ground fault is 11.7, almost 12 kilo ampere scaled value. The actual value is 9.4 kilo ampere. And then so it's ELM 345. I have conducted these values and I find a maximum value of 12 kilo ampere scaled value for this particular bus. Now the transformer is connected with ELM 345 and ELM 138. Now I want to conduct on this 138 because I want to select a safety circuit breaker for the transformer. So ELM 138 is here. I want to conduct the short circuit analysis. Again, single line to ground fault 2.8 kilo ampere is the maximum value. Not a maximum but a scale value is at this bus for single line to ground, and the scale value is 15 kilo ampere for three phase balance. 15 kilo ampere for three phase balanced fault current. Line to ground, again it's 12.9 kilo ampere, and double line to ground it's again 150 1597 uh, ampere, almost 1.5 kilo ampere. So again the maximum value is 3, which is almost 15 kilo ampere scaled value. Actual value is 12 kilo ampere. So we have to select an appropriate circuit breaker for this transformer connected in between power transformer 345 and 138. We can select it.